Data structures. What are data structures? According to Donald Knuth, The Art of Computer Programming, data structures/information structures are the different ways we represent relationships between data, pages 232 to 235. This representation allows for efficient performance of some operations. Example, a stack or queue allows constant insertion/deletion. A balanced binary search tree allows for logarithmic operations. Note well, data structures can either be static or dynamic. What do we mean by static or dynamic data structures? A static data structure is just a boring, lame data structure. Sorry, a static data structure means the size of the data structure is fixed from inception. That is, it cannot grow on demand. Now, a dynamic data structure is the opposite, where there is no fixed size and it can grow on demand like my empty bank book. I wish my bank book could grow on demand, then I would make myself extremely rich. But anyway, guys, the first data structure I'll be covering is a stack. I will implement this data structure in the C programming language. Peter Brass' book provides an implementation of the stack data structure on pages 1 to 9. My implementation will be slightly different from his. Fundamentally, a stack is a last-in first-out data structure, LIFO. That is, we usually have access to the most recent item inserted. We can imagine a stack S storing keys K1, K2, K3 to Kn. Note simply that K1 would represent the oldest item in stack S and Kn the most recent. If we remove Kn, then Kn minus 1 would be the most recent. This trend continues on. With the conceptual idea of what a stack is out of the way, we can focus on implementing the stack itself. I hope you have been thinking and wondering about the implementation of the stack. I will pose an interesting question, which is, how do you implement the most recent feature in a stack? Given a stack S, if I call the delete function for S, it would always delete the most recent item. How do we create this data structure keeping track of the most recent item? A solution is to allow each item to have a data field which stores the address of the most recent item after it. If we think of a stack, in reality, it's usually a set of objects that pile on each other. The topmost object is the most recent item on the pile, and we refer to this as the stack top. An important point to note for stacks are that we can only insert and delete from the front. Please remember, we can only insert and delete from the front of a stack. The insertion operation is termed as a push operation and the delete a pop operation. Some uses of a stack are, we can use a stack for the undo button in text editors. We can use a stack to check parentheses if they are balanced. We can use a stack for back button in browsers, and we can use a stack in the shunting yard algorithm. And that's it, folks.